You wake up, reach for your phone, and ask, "What's the weather today?" Or set an alarm for 7 o'clock. Within a second, a digital voice answers, acting as if it knows exactly what you mean. But how does a machine made of plastic and wire actually understand your voice? Computers don't have human brains, and they don't naturally know what words or conversations are. For a long time, the only way to talk to a computer was through complex mathematical code. These early machines were massive, and unless you knew how to type out very specific programming instructions, you couldn't use them at all. Humans are different. We learn language naturally as children, picking up on accents and the messy way people talk. A computer has to be taught how to process that mess from scratch. To bridge this gap, engineers created a specialized system that acts like a translator. It takes the words we speak and turns them into a set of mathematical patterns that the machine can actually process. This technology is known as natural language processing. It's the branch of AI that helps computers interpret and respond to how people naturally communicate. When you say, "set an alarm for 6:30, the AI doesn't look at the whole sentence at once. Instead, it shatters your words into smaller pieces. Engineers refer to these individual blocks of data as tokens. The AI then scans these individual blocks and matches them against millions of language patterns it learned during its training. It ignores the extra words and focuses on the markers for alarm and 6:30. Based on those markers, the system predicts what you most likely want it to do. It determines the correct action and sets the alarm instantly. The computer isn't thinking about your morning or understanding time. It's simply a high-speed calculator that connects the data points in your sentence to generate a highly accurate prediction. Before the AI can analyze your words, it has to hear them. This happens through speech recognition, the technology that listens to the sound waves of your voice and converts them into written text. This is a huge challenge because everyone speaks differently. AI has to be trained to handle thousands of accents, different speaking speeds, and voices that range from a whisper to a shout. The real world is also full of noise. In a busy railway station, your phone captures your voice along with screeching trains, echoing footsteps, and loud announcements all at the same time. In a crowded market, there are dozens of other conversations happening right next to you. The AI has to separate your specific vocal pattern from all that background chatter. Even in a roaring stadium, the system tries to pluck your single voice command out of a crowd of thousands. It's a massive math problem that happens in a fraction of a second. Because sounds can be so similar, the system's mathematical instructions can still make mistakes. If a loud truck drives by while you say, "Call Sam," the AI might process a slightly distorted sound and decide to call Pam instead. To make this technology feel easy to use, engineers have to constantly feed the AI new examples of voices from every environment to help it overcome the chaotic noise of the real world. When you put all these systems together, you get chatbots and AI assistants. These are programs that can have a conversation and perform tasks based on what you say or type. You might ask an assistant to explain the water cycle for your homework, or tell a chatbot to write a brand new story about a brave astronaut. It uses its training to generate a response that fits your request. But human language is full of words that have more than one meaning. Take the word bat. A computer doesn't know if you mean an animal or an object. If you say, "the bat flew out of the cave," the AI looks at surrounding words. Flew and cave help it predict you mean the flying animal. This surrounding information is vital. If you say, "he hit the ball with the bat," the words hit and ball guide the AI towards the sports equipment instead. This ability to look at the whole sentence is what makes AI feel smart. By using the words around a difficult term, the system can stop guessing and start making accurate predictions. This same pattern matching technology is used for machine translation, helping people from different cultures communicate even if they don't speak the same language. Modern AI doesn't just swap words one by one. It analyzes the meaning of the entire sentence first, and then it reconstructs that idea using the grammar and rules of the new language. This means you can visit a cafe in another country, type, "I would like a vegetable sandwich" into your phone, and the app will provide a natural translation that a local person can easily understand. However, cultural phrases can still be tricky. If you say "it's raining cats and dogs," a literal translation would sound very strange. The AI has to learn that these specific word patterns represent heavy rain rather than falling animals. Translation AI connects the world instantly, but human translators are still important for capturing the deeper feelings in things like poetry, humor, and complex stories. You are likely using these systems every single day. AI is helping when your phone recognizes your face, when it predicts the next word you want to type, or when it suggests a new song you might enjoy. It's also working behind the scenes in your email. Spam filters search for patterns like suspicious links or repeated advertisements to keep unwanted messages out of your site. Navigation apps study live traffic patterns to suggest the fastest route to your destination, helping you avoid road closures and accidents before you even reach them. In all these cases, the AI handles the data and makes a suggestion, but it cannot make the final choice. It can find a route, but it doesn't drive the car. It can recommend a song, but it doesn't know your mood. The AI is a powerful assistant, but you are the one in charge. It's helpful to remember that AI does not have a human brain or its own memories. It relies entirely on the data and patterns it has been shown to make the best possible guess about what you want. We do this by analyzing the meaning of words, converting speech into text, and bridging the gap between different languages. Think like an AI engineer for a moment. If you were building an assistant for a group of children, how would you design it? How would you teach it to be polite, to keep them safe, and to explain difficult ideas in a way they can understand? Engineers tackle these challenges every day. By understanding how these systems learn and predict, you now have the knowledge to help decide how technology will serve us in the years to come.